Now that you know how to tell whether a graph represents the graph of a function, it is now a good time to introduce to you how do we determine whether the function is a one-to-one function or not by using the horizontal line test. Very good. So stick around and let's get it. Before introducing the horizontal line test, we want to explain what we mean by one-to-one function, because that's what the horizontal line test determine. By definition, a one-to-one function is a function in which each output value corresponds to exactly one input value. A one-to-one function is just a function in which each x value have only one y value. The y values do not repeat. Again, a one-to-one function is a function in which the y values do not repeat. Each x value must have only one y value. That is a one-to-one function. So for our example, we have, is the area of a cycle a function of its radius? If yes, is the function one-to-one? So let's determine whether the area of a cycle is the function of its radius. What is the formula for finding the area of a cycle? That's A is equals to pi r squared. Now, for this to be a function, that means that each value of the area should have exactly one value of the radius, right? Now, since this radius is being squared, and we know that the radius cannot be a negative number because radius is a distance and distances cannot be negative, we say that from this equation, the area is a function of the radius, because for every single value of the radius, we only have one value for the area. That's it. Now, if yes is the function one-to-one, to determine whether this function is one-to-one, we can solve for the radius and see, because we've already said that for each value of the radius, you only have one value for the area. So let's solve for the radius by dividing each term by pi. So A is equals to pi r squared. Divide this term by pi, divide this term by pi. We have r squared is equals to pi over A. And if you have r squared equals to pi over A, to solve for r, we take the square root on both sides, and r is equals to, now you cannot take positive or negative because the radius cannot be negative. So we're only taking a positive value for the radius, that's pi over A. So because for every single value of the area, if A is any number, there will be only one value of the radius, which will be that positive value. We say that this particular function is a one-to-one function, and that's how we do it. It is now a good time to define the horizontal line test. Now by definition, if any horizontal line intercepts a graph more than once, then we say that that particular graph is not the graph of a one-to-one function. So we say the graph does not represent a one-to-one function. Remember, the vertical line test is used to tell if the graph of a particular relation is a function. Get that clear? The vertical line test is used to tell whether a graph is a function. The horizontal line test is to determine whether that function is a one-to-one function. There are several functions that are not one-to-one. So the horizontal line test will only tell us whether that function is one-to-one. That's all. Great. So let's look at one example and then we'll give you a practice question to do. Let's try another one. Now, for this graph, we know that it is the graph of a function because it passes the vertical line test. Let's determine whether it is one-to-one. Once we cross a series of horizontal lines in this graph, we realize that this horizontal line intersected the graph at more than one point. This one also intersected the graph at more than one point, and this one intersected the graph at more than one point. Therefore, this is not a one-to-one function, even though it is a function, but it is not one-to-one. So let's give you a practice question that you are going to do and submit your work in the comment section of this video. This practice question is on the horizontal line test. So determine which of our previous graphs in example 1 through 10 represents a one-to-one function. So we know that there were graphs that were function and there were graphs that weren't function. So we want to know those ones that were function. We want to know whether they are one-to-one function or not. So do this particular practice question and post the result in the comment section of this video, and I can assure you that we're going to go through each of you solution and give you feedback. So stay tuned as we introduce part 2 of this series, which will be on finding domain and range of all kinds of different functions. Thank you very much, and do not forget to subscribe to our YouTube channel. Bye bye.